So this is lesson number 28, Algebra 2, Complex Fractions, Rationalizing the Denominator. There's just a picture off my front deck where I'm sitting doing this lecture on September 14th. So just an idea of what it looks like this time of year out off my deck. So let's make this go away and get started here. So what we're going to do here is start out with complex fractions. And a complex fraction is basically one fraction over another. So if we have something like 3/4 over 1/2, that's a complex fraction. So what that means is we're going to take the denominator, flip it upside down, and multiply it. All right, different than what the book is going to teach you how to do. And then 2 goes into 2 once, 2 goes into 4 twice. Multiply and get 3 over 2, and we're done. Doesn't look like a very pretty 2. That looks even worse. All right, let's be done. You know what I mean. All right, so when we get into complex fractions in Algebra 2, though, many times we're dealing with letters like that. But the rule is the same. Flip it over, multiply. Okay, that goes away. And because we have a multiplication sign here, we can cancel across a multiplication sign. So we can cancel that b with that one and get a over x plus y. So not too bad there. All right, now let's go to one of the other examples, the second example there. And they give us a over a plus b. And that is over c over a plus b. So again, we're going to take that, turn it upside down, and multiply. So I'm just looking at this now. But notice, I've got an a plus b here and an a plus b there, so I can cancel, and I get a over c as an answer. Now, let's go over this canceling bit. Remember, the a and the b are locked together with a plus sign. They cannot be separated. So that means if we're going to cancel, we have to cancel the entire a plus b here with the entire a plus b here. It's kind of like this is in a parenthesis. They're grouped together with that plus sign. And if it helps to put a parenthesis around each of those, go ahead and do that. Because this is one unit and this is one unit. So we can only cancel the units like that. So I just need to emphasize that because too many students want to just cancel part of the a plus b and not the entire a plus b. All right, so let's go to the next part of this lesson called rationalizing the denominator. So in order to rationalize a denominator, you've got to have something to rationalize. So we're talking about when we have a square root or a radical in the denominator place. You cannot have a square root in the denominator, not because it's wrong, but because it's not reduced, it's not simplified. It's kind of like leaving your answer as 2 over 4. You know, you can reduce that to 1/2. So the best thing to do is what is most mathematically correct and reduce when you can. And it's the same here. If we want to get rid of that square root of 7, we must find something to multiply the bottom by in order to be able to get rid of that. But if we do something to the bottom, we also have to do it to the top. So 4 times the square root of 7 is 4 times the square root of 7. Can't combine those. Can't combine a radical and a number. Square root of 7 times square root of 7 is the square root of 49. Well, you know that the square root of 49 is 7. Okay? And that is our answer, which is the same as what we started with. We just simplified it. All right, so let's look at example 28.3 here and look at a continuation of how to do this. All right, so what is it on the bottom we don't want? The square root of 5. So let's multiply by the square root of 5. We'll ignore the 2 for right now. And that gives me 3 square root of 5 on top. And it gives me 2 times the square root of 25 on the bottom. So 3 square root of 5. What is the square root of 25? 5. So that then gives me 10. So I get 3 square root of 5 over 10. And if I can reduce, I go ahead and reduce, because I could, if this were reducible, this 3 over 10, I could do some canceling with this. Can't do anything with the square root of 5, but if this were cancelable, so for instance, if I had 4 square root of 5 over 10, I could cancel, because 2 goes into 10, 2 goes into 4, and that would be reduced. So if that's a possibility, go ahead and do that. All right, and let's continue on. 2 over 3 square root of 12. All right, so we have a couple different options here, and probably the easiest one would be not to reduce the radical first. We'll multiply it by the square root of 12 over the square root of 12. Gives me 2 square root of 12 over square root of 12 times the square root of 12 is the square root of 144, which is 12. So are you seeing the pattern here? When you take a square root times itself, you just basically take off the square root sign. So we have that. And so that gives me 2 square root of 12 over 36. All right, so I can reduce that. So let's look at it down here. Let's rewrite it, 12 over 36. All right, first of all, I can reduce the square root of 12, because the square root of 12 can actually be written as the square root of 4 times 3, right? And that's over 36. Well, what is the square root of 4? It's 2. So I'm going to take this 2 and leave it alone. And I'm going to take the square root of 4, which is another 2. So that second 2 is from this one. And I can't take the square root of 3, and that's over 36. So let's look at what I get there when I do the multiplication. I get 4 square root of 3 over 36. 4 goes into 4 once, 4 goes into 36 9 times, and I get the square root of 3 over 9 for my answer. Okay, so this answer that I got clear up here is correct. It's just not simplified, or in other words, reduced. So that's what we did here. So the first thing you want to reduce is your square root of 5. You want to simplify that. And the square root of 12. So the square root of 12, if you remember, to simplify that, you try to find two numbers that you can take the square root of one of them. So I could have used 6 and 2, but I can't take the square root of either one of those, so that doesn't help me. But if I took if I took 4 times 3, I can take the square root of one of those. The square root of 4 is 2, so that lets me pull a 2 out, leaving the square root of 3. So that is the most simplified of the square root of 12, is 2 square root of 3. Now you can tell pretty easy whether or not this is actually the reduced form of the square root of 12. And the way you do that is the number that's outside, you square it, multiply it by 3, and if you get your 12 back, then you did it right. So 2 squared is 4, times 3 is 12. Okay, so that's a quick and easy way for you to determine whether or not this is the simplified square root of 12. All right, so that is it for lesson 28.